Hey, what's up, everyone? Sorry for the lack of content lately. Obviously, been really busy. For those of you who don't know, I have my AWS exam coming up here in a couple days. Well, about a week and a half, 2 weeks maybe, and I've been studying for that. So that's why I've not been streaming. That's why I've not been putting out videos. Super busy, but that's okay. I want to talk to you today about some stuff that's actually been happening in a recent release from 343 Industries and Microsoft. That release being Halo Infinite. One of the big things that's plaguing this release outside of the cache shop is the unreliability of the servers. And I want to clarify, I don't actually have direct insight into the server issue, but I do have a fairly good idea of how they're doing it and what's happening. So one of the things that Halo Infinite started doing is it started moving towards this cloud-based infrastructure. What that means is that everything can be on a quote-unquote dedicated server. That means that that server only exists to run Halo, and this Halo, or this server, isn't someone just hosting the match. So you aren't reliant upon other players or their poor internet connection, or if they suddenly lose connectivity, the match ends. So if if one player from a match leaves or disconnects, then those other 7 players don't see a host migration, they don't see a delay in gameplay, and they keep playing as if unaffected. Now, how though are they doing this in the cloud? So the cloud allows them to work a little bit more interestingly because they can use a rather new technology within the past couple years called containers. If you don't know what a container is, that's okay. You don't really need to have a super great understanding of it, but a container is basically a spun up instance of a full computer server that can then be destroyed or recreated on command. This is an entire virtual thing. Think of it as in, if I were to take a box, shove everything inside of it I need to run a Halo game, and then say, hey, everyone, connect here, now we're ready, and I can do that fairly quickly. Set that up, and then get rid of it. That's why we're seeing all of this issue. A lot of these games are most likely being run on Kubernetes or Docker containers using Kubernetes. So if I go into my handy dandy paint so you can see what's happening, I have a diagram already pre-exposed here for you. This is my game container here, this little database looking symbol. I know it's technically a database symbol, it's not a computer symbol, but I'm using it because, hey, it looks cool, and I spent some time making it. It really was just a couple seconds, but hey, let's examine what the actual process looks like to connect and the life cycle of this container goes. So I'm going to move this over here to start. Up here we have our master host server. This master host server receives a request from a player that says, I want a game. This server then says, oh, wait, okay, I need to find other players. All these other players then come in and say, hey, we all want games too. And there we are. That's a really bad line. And they're all saying, yep, we want games too. Now this says, hey, I have everyone I need for a game. We have a lobby found. Let's go ahead and spin up our game instance. So the server goes through and it tells Microsoft Azure Services, I need a virtual container to host this match. So Azure goes through, says, okay, give me your randomization properties. And then after they make their randomization properties, Azure comes back. So this could be things like, what is the game mode? What is the map configuration? As we've all noticed, different maps have different configurations that are, from what I can see so far, dependent upon game mode. So if it finds a game mode and it finds a map, say you have Slayer on, I can't think of a map right now, but we're going to go with Blood Gulch. It's a classic. So let's do this. Let's look it up. Halo Infinite maps. Isn't one like Training Grounds or something to that effect? Sorry. Aquarius. We'll go with Aquarius. First one I saw. So say it says Slayer on Aquarius. And then Azure says, oh, hey, I know exactly the container to grab. It goes out and grabs the Docker file for and I'm using Docker as an example because it's a specific containerization service. So these Docker files have everything inside of them that they need to be able to create a container or an instance of this. It goes through, creates a copy of that Docker file, kicks it out there and says, all right, here's everything I need, creates a virtual machine. Azure comes back and says, hey, that container you want, here it is. We're ready to roll. So now we have our container. All of the participants then get redirected and connected to the map, and a handshake is established. I'm also going to, before we do that, I want to make sure I have another one of these on my clipboard. That way, because we're going to use this another one, I don't want to have to redraw it. So now all of these containers, all of these players then connect handshake to the container service, and they say, yep, we know the connection. Here's my secure authentication token. So only I am updating myself. That's how the server knows when a player goes to say, hey, I'm moving. Hey, I'm shooting. It sends its own request token in and says, only I have this token. So therefore, you know that only I can be updating my information. So it goes through. The match is played. Everyone's happy. Yay. Now, after the match, what happens? All of these players, and this is kind of where the problem lies. So, they go back to the lobby service. The lobby service oh no, I don't want that one. The lobby service then indicates the match is over. So from here we move on down to here. This lobby service then destroys this container. So this container is no more. Now, big brush here. Big old red brush. This container is no more. This match instance is gone. It saves off the metric data about like performance, who was in that match, all that kind of stuff. That's all saved off in a database somewhere. So all that information is still accessible, but the actual match itself is gone. You can't go back through and replay that map in that container ever again. That container no longer exists. So then what happens is that lobby then says, hey, we're going to go and terminate our lobby. So this goes down and it ends its cycle, terminating all of these instances, all of these player instances. So all of this connection is all gone. Now, obviously, give me a sec here, I'm going to make this a little bit cleaner. Obviously, this isn't ideal for the players because what we're used to for Halo games is a persistent lobby state, meaning that even if they're running on a dedicated server, that lobby always exists. Or if they're not running on dedicated servers, they're just running on Microsoft servers because it's a Microsoft game. They're just, that instance for that, it just goes through and it says, hey, I have this, you're putting this data in here, or at least I can easily get this. That always exists, so long as that lobby exists, and there are lobby merges that happen, so lobbies will get moved together, yada, yada, yada. Now, what can be done? So that's kind of explaining why there is that delay between every game. A new lobby must be made, a new container containing a single game must be made, because it is a single game. It is one game mode inside of at one map for a single lifetime. Now, how can they fix this? There's a couple ways, actually. So the reason, but first let's kind of say why they did this. They did this for a largely cost-saving perspective. If we were to go through, and if I were to pull up the Azure container costs, and we were to say Azure container instances pricing, and we were to go down and say how much does it cost? Now let's be a little charitable here, and we'll say so what what these go off of is we're gonna assume these are all running Windows, and these are just all it's using is memory, and all it's using is virtual CPU power. Now we're gonna assume it's using 4 gigabytes of CPU. So we have our 0.0000015. I'm going to pull up my calculator here. We're saying it's using 4 gigabytes, and they are doing a per second 0.0000015. Oh, wait. One more zero there. and we're going to multiply that by 4 because we're using 4 gigabytes of RAM because I don't necessarily need to do a lot. All I need to do is push out a little bit of data to everyone. Not a super huge intensive process, and in fact, I'm not actually pushing to people individually. I'm receiving requests on a request line and just giving them back out and saying, hey, here's updated requests, I need you to get this. Your computer's doing a lot of the work here. So we're going to say that's 4. So we get this number, and then we're going to multiply that by 60 for 1 minute. And then I'm going to go for the average length of a match, which I believe is 12. So the actual cost in virtual RAM is 0.432 cents. So that's less than a penny for a match. Now, let's look at what it costs for a CPU for a match. If we look at this as, again, I'm going to give it 2 CPU cores, that are 2 CPU units. That allows for 4 simultaneous core computations. That means that 4 things can be happening at the same time. And again, this is probably overkill because it doesn't actually need to process all of this information. So let's see what this looks like. Now I'm going to give it 2, and then we're going to buy 60 again, and then buy another 12 for 12 minutes. And that's roughly 1.944 cents, so roughly 2 cents there. So they're paying less than 3 cents for each of these matches. That's why they're using containers. This is a very cheap and very cost-effective way to run a game, as compared to, if we look in Azure, their pricing by product. Let's look at their virtual machine compute services. This is what they would be running on normally. Normally there'd be a set of applications running on virtual machines. And I want you to know too, I'm oversimplifying. I'm being overly generous for how much they're actually using. There's a reason you kind of want them to be a little overly generous. You would be probably in a bit better situation being overly generous, because then if there's issues that happen, or there's, say, some sort of compute backup, I can take something off one thread and throw it to another, and I can do multiple in process. I have a little bit extra RAM I can play with, all that kind of stuff. So let's look at here. I would guess if I were, let's take that at our hourly pricing. So we have this plus our 0.00432, I believe. All right, and so an hour, we can get 5 games on a container an hour. We're assuming that we're just doing 1 game. So 5. We're going to multiply this by 5 to get a total of 11 cents. Now, of course, we're seeing all of this RAM, temporary storage, cores. These contain this price per hour. It may look really low, but this is very low compatibility. What I'm actually going to do is I would say that it is going to be run on a if it were me and I was running this, I would probably be rerunning on either a generation or a D2AS. The D2AS is a super high level, or it's not a super high level, it's just it's much faster than a lot of your older stuff. So it's going to run at a constant dedicated server rate at 0.86 cents an hour. Now, while yes, this is technically a little less than what we're paying for our container, like I said, I'm over budgeting our container. In all reality, we can probably cut this in half. The other reason to go for a container is you don't have the long, consistent fees. So if you don't have players using this server, say I spin up 100,000 of these machines, it's going to cost me obviously more than if I were just to make each container, because I have downtime. So there's non-peak times, and I can either run it as an auto. I can also do that through auto scaling, which is adding more resources as you need them or as traffic demands. But you're still paying more because instead of running a single container, now you say, oh, I've reached 60% traffic, bring another instance online so I can balance that traffic down. So therefore, now you're doubling that 8 cents to 16 cents. And of course, you can get, there's a lot of very complicated ways and things that all this happen. But how can 343 Industries fix this? Now, I really want to clarify here, I don't work in Azure. I used to work in Azure. I did a little bit in Azure, and I do some personal things in Azure, but my focus is mainly on AWS. I am currently going for my developer associate. That's the test I've been studying for. So I don't have the exact the exact Azure solution. If I was in AWS, I could probably easily make a solution for them, but it doesn't. It's not always the same. So what I would do is, if it were me, I would make a virtual image of a server fully ready to roll, because with all of the maps, all of the game modes, all of the configurations loaded onto it, and then the lobby is made. So this being, let's go back to our example here. This being, of course, let's get rid of all of this junk in the middle. And we're going to go through, clean it up, because obviously we didn't get everything, and that's okay. Just make sure we get the last little bits here. Make it nice and clean for us. So our lobby would actually now be this image or this container that we build. Now, it doesn't necessarily need to be a container. It could be just a machine image, and that you can create and destroy on demand. That is actually a thing that both Azure and AWS offer. Really interesting stuff there. But, oh, I don't want red. I will stick with the thicker brush size. Then what would happen is each player goes to and connects to a... Sorry, I want to move this down. Goes through and connects to a lobby handler service. That lobby handler service, so here I'm making the connect to the lobby handler service. This lobby handler service then redirects them down to their newly created lobby. So the first time that lobby gets created, it takes a little bit, and that's fine. Most players are willing to wait 20 to 30 seconds if it means subsequent waits are less. That is generally the approach that most people would see, and even then, this would actually be a fairly rare instance. This would only be for new lobbies. So this lobby would still exist if this one person left and a new person came in to fill their spot. This lobby still exists. Now you just swap out one of the seats. That's fine. So now we have this virtual image running until, say, half or more of the lobby disappear, and then we say, okay, now we can no longer fill seats, let's merge lobbies. You then take the less longevity, you then take the lobby that has the less longevity and migrate everyone to that lobby. The reason why we do this is because of stability reasons. There's less chances for caching errors, there's less chances for RAM corruption, all that kind of fun stuff. And so generally you want to move to the newer service. Now, all of this can be done fairly cheaply, fairly cost effectively. You might see a small rise in the prices, but in all reality, the prices are not going to be as high. These are also certainly not as high as legacy on-premises prices. And I want to also clarify too, this isn't someone utilizing a third-party service. This is Microsoft using their own cloud offerings. Azure is a Microsoft offering. This is effectively just a line item on the budget that they're charging other people to keep their servers up and running. Microsoft does this all the time with other projects. Ever download Microsoft Office, like a Windows update, something, that's all kept on an Azure server somewhere, and they just keep it running. They also do this for their work environments. All of their work and images and containers and everything like that, it's all kept on these Azure services. And while you may have like a local desktop you're working on, all of the code repositories, everything is all on their Azure service. So in all reality, they're not actually paying for these servers if you really get down to it. So this would be a very, not only cost-effective way for them to solve this large problem that I know I'm not the only one noticing, and it would be a very elegant solution to improve player happiness, improve game stability, and ultimately improve an experience that we've all been enjoying and we've all been wanting for a long time. I know I personally have been waiting for Halo Infinite to come out ever since it was announced at E3 in 2018, so it's actually been over 3 years now. Math is hard right now. Sorry, yeah, it's been about 3 years now. So I've been waiting for this for a while. I'm sure I'm not the only one in there. And while I gotta say, the core gameplay is incredible, it could be better through the way that they handle their lobbies. Now, this isn't to say anything about the whole debacle with the lack of Slayer or the lack of other playlists. This is just to kind of say why and what the technology behind the lobbying looks like and explain the problem, so that way we can start maybe saying, hey, let's work towards a solution. I'm not using this as a way to temper people. I'm not using this as a way to calm people down. In fact, if you are upset after watching this, that's fine. Just please don't be upset at me. Like I said, I don't actually work for 343, and I don't work in Azure. I work in AWS. This is just a one engineer's, developer, software engineer, computer scientist best guess at what the actual underlying technology behind all of this is. Obviously, I don't have access to their source codes. I can't tell you if this is the exact thing. This is just, from my experience, the best thing I can estimate and the best thing I can determine coming out of this. So yeah, I hope you all enjoyed the video. I hope you all found it very useful. If you do, feel free to give me a like, and I don't normally do videos like this. I'm starting to get more into tech and gaming and stuff, so feel free to subscribe if you want, or just leave a comment, tell me what you think, how you'd like to see Halo Infinite evolve with their servers and matchmaking in the future, and I'd really appreciate it. And I'll talk to all of y'all later. Alright, bye.